Okay, good morning, everyone, and welcome to day 2 of EAMS. So we've got 3 lightning talks this morning from Jessica Banks, University of Liverpool, Frauke Sprengel in Hanover, and Mario Orsi, University of the West of England in Bristol. So that's our program for this morning. So we're going to have 3 lightning talks, after which there'll be an opportunity to ask questions. Just a reminder that the questions to pose to the speakers, there's a place to do that, and that's on the Moodle site. I'll go across to that now, if I can. Lost control of my screen, bear with me 2 seconds. So over in the talk section of the Moodle site, you'll find a questions link for the session this morning. If you could put questions there, and I'll ask them to the speakers at the end of each talk. Okay, so first up this morning, we have Jessica Banks from the University of Liverpool, who's talking to us about assessing the mastery of introductory pure mathematics with Mobius.
Hello, I'm Jessica Banks, and I'm part of the Mathematics Centre for Enhancement in Education in the Maths Department at the University of Liverpool. I want to tell you about an auto-graded assessment I designed for an Intro to Pure Maths type module using the Mastery Assignment functionality in Mobius. My only connection to Mobius is as a user, and whilst some of what I'm going to say is about assessment options available in Mobius, most of the ideas can be applied more generally. The assessment is part of a module taken by the straight mathematics students when they first arrive at the university. Although it incorporates a range of different material, the module seeks to introduce the students to what university mathematics is like, particularly the sort of abstract, pure mathematics they haven't really seen at school. It's intended to help students develop core knowledge and skills they need to succeed on a mathematics degree, some of which we tend to assume don't need explicit teaching. Traditionally, we set out the syllabus for a module, and a student can achieve a pass by learning 40% of that. Some content is more central than other content, and the idea is that weak students learn the most important 40%, while stronger students also learn the more peripheral material. In practice, it often doesn't work like that, as students choose for themselves which sections to focus on. This can be particularly problematic with foundational first-year material, leaving students to continue with their studies without having mastered some of the key concepts that underpin their studies. I wanted to design an assessment that ensured students couldn't avoid learning the most important ideas. Accordingly, students are required to get all the answers right, eventually. Those who are already comfortable with the material simply complete the assessment and move on. Those who find it harder have the chance to improve their understanding and then try again. In terms of deciding the specific content of the assessment questions, I asked myself the question, what things are so important that I would be prepared to fail a student who was not able to do them by the end of the module? Now let's have a look at some of the individual questions that I created for the assignment. First, here's a basic multiple choice question. This is using the Maple functionality to draw the graph. One aspect of this question, which doesn't play into the assessment itself, was that I wanted to remind students that not all functions look like polynomials, trig functions, or exponentials. Here's another multiple choice question, this time with multiple selection rather than single selection. In this case, I've used a static picture file for the Venn diagram, while the set names and the combination of sets requested varies. This question uses the most mathematical question type, which is graded using Maple code. It's about making sure students understand that the variable in the function definition is just a placeholder. It was inspired by a tutorial I taught once, where I spoke to a number of maths students who, given f of x, were unsure what f of y was. The function here varies, as does the notation. There are a variety of different mathematical objects you can ask the students to input for this question type, one of which is Greek letters. Sticking with the theme of mathematical language and writing, here's a question to help students with learning definitions. Again, the notation varies. This is a free text box with a fixed list of one or more phrases for the students to match. It's also possible to include partial marks here, which in this example can be of use to students who are not yet completely fluent in mathematical English, i.e., all of them. However, since you have to specify every word you are happy to accept as an answer, I decided this question was only really suitable for formative assessment. Instead, for summative assessment of the same content, I settled on the matching question type. Here the students have two lists that they have to pair up. This is another question focusing on reading and speaking mathematics, specifically the symbols for all and there exists. As you can see, this uses a drop-down box to offer students possible phrases. One thing to note here, though, is that you cannot fix the order of items in the list without giving away information about which answer is correct. If you need to keep the options in order, multiple choice questions work better. Here is another question designed along the same lines, this time looking at negation. As you can include LaTeX in the drop-down list, these meant I could ask the students to input symbols that are not included on a keyboard or in the palette for the Maple graded questions. I consciously chose the layout of the boxes to emphasize to the students the block construction of these sentences. Another question type, which I like partly just because it seems slightly more fun, is the sorting question. It can work wherever you have objects with a unique ordering. By default, they are arranged horizontally, but by adding some custom CSS, I was able to create a vertical version too, which is better for longer text. I did create some questions sorting the steps of a proof into order, but they proved to be harder than expected. Finally, this last question uses the Math App question type. This is really an educational bit of Maple embedded into Mobius. This is the only one of these questions I've managed to construct, and that was by modifying some existing code. I think it would be interesting to explore what more could be achieved here for someone who knew enough about these Maple tools. So how does the mastery assignment type in Mobius work? You organize your questions into groups and specify how many questions the student needs to correctly answer from each group. Each question is graded as the student completes it before they move on to the next question. The questions are just the same as in other Mobius assignments, so have as much variation as you've chosen to code. If a student gets a question wrong, they're given another question to do from the same group, which will often mean the same question with new numbers. As students have an unlimited number of tries at a question group, there's the obvious problem that they might get the correct answer simply by guessing, especially, for example, with true-false questions. Mobius allows you to set penalties for wrong answers, in the sense that wrong answers cause the number of correct answers required to increase. This is great in that you can reduce the likelihood of students correctly guessing the answer, for example, by requiring 2 correct answers in a row. The format for these penalty rules is overly restrictive, though. Allowing more flexibility would make this assessment type much more powerful. In terms of practicalities, I made the assessment available to the students throughout semester weeks 6 and 7, after we had covered the relevant material in class, and those who had not passed had another opportunity to complete it in week 11. They had access to anonymous formative assignments beforehand with similar questions. I also split the assessment into 4 sections that they could tackle independently. I deliberately set a deadline partway through the semester so that the students had a specific date to work to, rather than just forgetting about it until the last week of the semester. I was also keen to have a specific date at which I could identify students who did not seem to be engaging and might need additional support. But that's a different story. Thank you for listening to this talk. I hope it gives you some ideas you can use in your teaching. Hello, I'm Jessica.
Okay, so Jessica has joined us this morning. So if you have any questions, please do pop them in the questions section on Moodle there, or I will pick them up from the chat in Zoom as well. I'll kick us off. So Mobius has quite a fancy looking input widget for mathematical expressions, Jessica. How does that play on sort of mobile devices? Does it work okay on there as well?
I don't have much experience of using it on a mobile device, so we were using Blackboard. We're in the process of moving to Canvas, and I know that works well on a phone, and that Mobius seems to run reasonably happily on there. As far as I know, yeah, I mean, it's running HTML. As far as I know, it functions as well as anything can on a small screen. Well, okay, the Mobius isn't, the version of Mobius we currently have maybe doesn't have as much adaptive HTML as maybe it could do. But I don't know, I've not heard students complaining about that. I don't know if that's that they're not doing it on their phones, but we use Mobius fairly widely in our modules and haven't encountered complaints about that.
Fair bit of discussion on the Zoom chat here about inputting Unicode mathematical symbols rather than using widget. Is that something that's supported by Mobius?
Well, so what we found, so Mobius has, particularly the Maple graded box is the main one that it's relevant to, and there's 2 versions of the box. You can have a small text box or a large click button box, and we've chosen to stick with the large box most of the time because that prohibits input of Unicode, whereas the small one allows you to input Unicode and gives you the option to check that it's invalid. But if you don't click on the button, it just marks your work wrong. So we originally had a lot of problems with Chinese students who it looked like they'd typed in the correct answer. So, I mean, there's always an issue with input of answers. We operate an email that students can contact if they think their work's been marked incorrectly, so that we can go back and change it. And that can be because the student has input their answer wrong, or because we've coded it wrong, or because there's a bug in the system, or you get various different things. So one of my tips is trying to make the input as natural as possible and making it clear as possible to the students what they should input. So if you put the X equals there for them, because otherwise they will type, some of them will type it themselves, for example.
Okay, thank you. So I can't see any other questions. I'll ask one more. So your disengaged students, you said you give them a nudge, which is how many of these students were there, and was the nudge helpful? Or?
So this was our first year. We take in, it was about 80 students in the first year. We then gain a lot of Chinese students from second year onwards from our partner campus in China. So it's a relatively small cohort who are then going to suddenly find themselves in a big cohort the following year. So we did then follow up with, so there were other exercises as well, and we followed up students that hadn't engaged, and some of those continued not to engage, but there were some also where we picked up on circumstances that we didn't otherwise know about, and so we found that quite a useful way of patching into our sort of support system, which was part of the deliberate design of the module.
Excellent. Okay, thank you. Thank you very much for very interesting talk. I think we'll move on. So our second talk is by Frauke Sprengel in University of Applied Sciences and Arts in Hanover, Germany. And it's about experiences of semi-automatic migration of problems from a long Kappa system to Moodle stack.
Welcome to our talk, First Experience with Half-Automatic Migration of Long Kappa Problems to Moodle Stack. My name is Frauke Sprengel. Up to now, we run several different learning management systems in our department. And so we have Moodle, we have Long Kappa, and we have an extra system. We do documents, slides, and file upload of homework, and we do computer-aided assessment. In mathematics, in theoretical computer science, and also in programming courses, we have built-in software here in Long Kappa. We have an extra tool, an external grader based on JFlat, and here we grade Java programs with Graia. And of course, this is not very comfortable. We want to have all in one for us and also for the students. This is a simplification. And so we want to have all what a learning management system can. And we want to have computer-aided assessment in mathematics with Stack, in theoretical computer science with Stack, and in the programming courses with Graia, which is plugged into Moodle with Grappa. And we also can plug in this JFlat grader into Moodle with Grappa. This is a middleware developed at our university. But what we do have now is Long Kappa, and we decided for Long Kappa almost 10 years ago or so, because it has a large shared resource pool. So we have a lot of problems we can use for mathematics tests and so on. And it's really a homework machine. So it's also a learning management system, but it's really good as a homework machine. But what the students did not like, it's really old-fashioned, at least from the look and feel. And what the IT does not like is they have really concerns about data security, about privacy, and so on. And it's not really good that we have the latest release in 2017. So, there are really concerns about data security. So we want to try to move from Longkappa to Moodle completely. And of course, we have a lot of nice problems. In Longkappa, we want to use also in Moodle Stack. And so we got the idea, let's try to write a software to support the migration of problems. And you see, of course, we cannot do it for all problems. We have good support for many types of problems. We also support conditional hints. Of course, the text is not a problem. The images in Longkappa, we export and we store it in scalable vector graphics to import it in Moodle again. We have GNU-plot in Longkappa. We can use it in Stack. We have also Maxima programming parts we can use, and multiple part problems we can also convert. Of course, in Longkappa, the problems use Perl. And if you try to migrate Perl to Maxima, this is not really to be automated. So of course, we can migrate simple Perl programming. We can migrate conditional blocks. Not all, so partial support. We have in Longkappa problems in combination with essays, so we try to have a workaround here, and we also can have multiple parts with using the student's answer. You see at the next part here, we do not support it in a whole. So if you have to solve in Longkappa part step by step, you can't do it in Stack up to now. If you plug in external tools in Longkappa, you can use randomization. Up to now, we do not have it in Moodle because you cannot combine Stack and JFlap. Some authors write elaborated Perl libraries, and of course we have problems with this. And there are some special type of problems we cannot migrate, but these are only a small percentage of the problems we have. So what is the algorithms you have to follow when you want to migrate your problems? You have to ask the authors of the Longkappa problems whether they allow migration and republishing. You have to get the source code of the problems. You run our program, and then you have to edit the Moodle problem. And sometimes it works good, sometimes it works not so good, and sometimes it doesn't work. Then load it into Moodle. Then you hope the best, and of course normally you have to edit again until you are satisfied with your problem in Moodle. I did this with about 20 homework problems per week this term. And this was really possible in parallel to Corona. And depending on the problem, some are easy, some are not possible, some need a lot of work, and something you have really long code in Perl, you write one line in Maxima and vice versa. So you have all kind of problems you may have, but really it's a good support. If we didn't have that, then I think we would have stick to long cover this semester. Well, I also asked the students what they did like and what they dislike. Of course, they liked that they now have all in one place. They like the look and feel of Moodle better than Langkappa. But there is a but. Of course, they did not like that Stack is slower than Langkappa. And sometimes they had really problems to really get that they have the right appearance of the problems in their browser. So I have to ask them to change the browser. And we did not have this in Langkappa. Our software is still work in progress. Up to now, we only migrated problems in German. Of course, most of the things can be done in every other language. There are plans for internationalization. At least we want to support English problems. You can get it here from this link from GitHub. And if you have problems or you think that we have maybe a new release now, then please contact me under this email address. Thank you for your attention.
Thank you, Frauke. Very interesting talk. I think other people who may have tried to migrate questions from one system to another probably have quite a lot of sympathy. Okay, so again, I would take questions through either the Moodle. Sanguine, developer of Stack, of course, asks, are there any features which you would like me to add to Stack to either make the conversion easier or better support the functionality that you're using already?
No, at the moment I do not have an idea to improve Stack. Of course, there's a multi-part problems, but I think maybe stateful will be a good idea to have a look at. But this is really what is the thing we have to think of how we migrate the problems with multiple parts, doing this part by part. So this is the other thing is we have randomized problems where we have a part something was is good in Stack and something where we have an essay part. We have the solution already in Langkappa so that you get in general feedback. You can display it. But at the moment we have a workaround that we have to combine two problems. So we have a Stack problem and an essay problem. So we have two problems. So it's well, it's work. You can do it, but so if you can include an essay part in Stack, that would be nice. So with file upload, this is what what my wish would be.
Okay, thanks, Frauke. Chris has made a note in the Zoom that there is a notes input that could be used for essay style questions. So maybe you can follow this up with Chris after the session. Okay, so I think we'll move on to our last talk. Thank you again, Frauke. It was very interesting. So our final talk of this morning session is from Mario Orsi, University of West of England in Bristol, about the successes and challenges of a trial with numbers.
Hello, my name is Mario Orsi, and this talk is an account of my experience of trial in numbers in my teaching at the University of the West of England, also known as UW Bristol. I suspect many of you already know what numbers is. However, let me just summarize what its key features are. Numbers is an online platform for assessments and learning activities. And I want to stress that in my experience I found numbers very useful, indeed not only for assessments, but also for developing teaching and learning resources. Numbers is free and open source, and it's developed at Newcastle University. A core feature is the high level of randomization, meaning that new random values are automatically generated every time a question is loaded. Numbers is great for maths, but it is very versatile. In fact, I personally used it in general science subjects. It has nice collaborative facilities, such as shared spaces for team members to work together. Numbers also has an active community that is responsible for a large database of questions that really helped me starting out. And I'm pleased now to be able to contribute to it. My experience so far, over the past academic year, I've used numbers in 3 science modules with around 200 students from the first and second year. Thanks to randomization, students could practice as much as they needed, receiving instant feedback. Also, thanks to randomization, it was possible to give students practice questions, which were very similar, if not sometimes identical, to the assessed questions. This would make assessments more transparent because it removed ambiguity in marking criteria. Thanks to marking and feedback automation and the substantial time saving related to this, I was able to set extra assessments over the year. This replaced traditional high-stakes final term exams, and ultimately it reduced exams-induced student stress. The feedback received on numbers has been incredibly positive. These here are just a few of many more positive comments, where students mention they really appreciate how they find practice questions useful, how assessments are made clearer and more fair through the use of numbers, and how anxiety is reduced. In terms of exam results, the introduction of numbers correlates with a slight increase over the previous years in terms of mean mark and also percentage passed. While it can't be claimed that this effect is significant or even causal because of the many variables involved, it is nonetheless very encouraging. What definitely improved was class attendance in the past year with the introduction of numbers. So while lectures are normally well attended, in tutorials and practicals attendance used to be very poor. This is despite me constantly stressing how tutorials and practicals are much more important than lecture. Anyway, in previous years, before the introduction of numbers, turnout would typically be less than 50%, and it would even decrease throughout each semester. This was clearly disappointing, so we were really pleased in the current academic year that's just finished, to observe that with the introduction of the numbers monthly tests, attendance substantially improved, remaining consistently over 50%. This year there's also been a drop in exam no-shows. So previously around 4% of students wouldn't even turn up for their exams, while this halved to 2% this year for the numbers exams. Of course, these results cannot be entirely explained by numbers, as another big change was the shift from end of term to monthly tests. However, given the numbers practice questions were used heavily in tutorials and practicals, and also considering the comments in the student survey feedback that I mentioned earlier, I am quite confident that a significant part of this improvement is down to numbers. Okay, now for the challenges. A problem we experienced is that up to half of the exam marks are not recorded in the grade center. This is a known issue of the SCORM exams in numbers, and it's due to a bug in Blackboard. We adopted a workaround which involves students taking a record of their attempts, either printing a PDF or taking phone pictures, then checking their grade center and email the lecturer if a mark is missing. This is, however, problematic because students can forget to take a record or to send it, so the lecturer ends up spending time chasing marks. The good news, in principle, is that the numbers LTI software is available and provides a solution. However, the bad news, for me at least, is that my institution is unwilling to support such LTI. UE follows strict architectural principles involving approval of only cloud-hosted software-as-a-service solutions. This means that they've rejected the option to run the LTI on an in-house server or even on the cloud via Heroku, due to required installation and maintenance efforts. We are now pursuing an alternative proposal which involved setting up an external contract. An ex-colleague of mine happens to run a small IT business, and they are offering to provide the full numbers LTI service. However, this is still not being approved, as there is a perception that the admin efforts required would be excessive. Now, if anyone in the audience from other institutions is in a similar situation, please feel free to contact this company, Main Bioanalytics. You have the details there on the slides. And let me know if you manage to contract it, as such evidence should really help my case. To conclude, my trial of numbers at UE resulted in more engaging and interactive learning resources, more authentic assessments, where it's harder to cheat, especially compared to take-home exams, more scope for collaboration, and very high student satisfaction. There is an open challenge in relation to reliability of recording marks in the grade center, but there are effective workarounds for the time being, and hopefully a proper solution is on the horizon. Thank you for your time and attention.
Okay, thank you very much, Mario, for a very interesting talk, looking at some of the successes and challenges of implementing numbers. So a question from earlier in your talk from James Fody. Why do you think numbers improved attendance in tutorials? What's attractive in its use that made that change? Is it because it was something new?
Yes, thank you. I wouldn't say because of the novelty. If anything, doing something new is sometimes a bit of a turn off. I think the big important point of using numbers is that students can see very clearly by themselves without even needing me to convince them that what they do in the tutorial and the practical is directly going to affect positively their assessment, right? Because it's completely aligned by design. The questions in the practicals are exactly the question that will be in the assessments or very similar. And it removes the annoying question of whether something in the practical will be in the assessment, because by default, that's yes, that well, or it would very much could be. So I really think it's because the students don't need convincing that what they do in those sessions is absolutely important and relevant for their assessment.
Can I ask a follow-up? What was you mentioned the change in the balance of in-course assessment and exams. What was that balance originally before you brought in these tutorials?
The what, sorry?
The balance of final exam and in-course assessment, was it 100% final exam before you brought these in?
Right, so before that, for the module, it's still 50% exam and 50% coursework. Previously, there were 2 exams, one at the end of each semester, whereas with numbers, it was 6 tests, once every month, more or less, throughout both semesters.
Thank you. So if you comments on the LTI hosting from various places. It's a story we're familiar with. Phil Walker in the Zoom chat says he has the same issues. I think that's at Leeds. I was going, so the two points here. So Karen Henderson makes a comment on the Moodle site that the reluctance maybe because UE supports JUICE. My question was going to be, how large is the user base for numbers at your institution? How much weight is behind this push to?
Yes, this is one of the pushbacks that so far it's around 200 students. Which, you know, if you multiply by £9,000 that they pay, I still think there is a strong case to spend a relatively small amount of money to implement an LTI. But yes, they would claim that 200 is not enough. However, next year there will be a foundation year course with over 100 students that will be using numbers, so that's already going to push it up. And there will be other people that will come around to it, especially now that it is going to be really critical to have good online assessments, reliable, easy to use systems. So yes, it's a long game. We'll see where we get.
And just exploring Karen's point further, what is it that you feel that numbers gives you that JUICE may not? Where's that sort of unique area that you need numbers for?
Yeah, hi Karen. We've been chatting about this offline. Well, I'm waiting for an account to be set up for me on JUICE so I can try it. I'm very happy to try it. If it works well, next year I will give a talk about how JUICE works well. We'll see.
Okay. Okay, so I think we've explored all the questions there. Thank you very much, Mario. That was a very interesting talk.
Thank you.
So, thank you. So finally, I will just bring up the program for this afternoon. So a reminder, we have 2 more talks this afternoon. So we're exploring again the recent experiences of using online exams thanks to the coronavirus pandemic. So there's talk by George Kinnear, Stephen O'Kagan from Edinburgh. That's at 4 o'clock British Summer Time this afternoon, and then I'll be finishing off the day talking about our experiences with numbers here at Newcastle. So I'll say thank you to everyone and hope to see you all, or some of you at least, this afternoon. Thank you very much.